In this experiment, we're going to investigate Coulomb's law, and we're going to look at the effect that the charge has on the repulsive force. The way we're going to achieve this is we have two spheres that will have a small separation between them, and we're going to charge them up by applying a high voltage up to 4,000 volts on the two spheres, which will cover them in negative charges or positive charges depending on how it's connected to the terminals. The charges will repel, and we can measure the size of that repulsive force because one of the spheres is sat on a top-pan balance and will record an increase in weight as the charge is increased. So here's our setup, and you can see the two spheres. The top sphere is connected to the red terminal, so the positive terminal on the power supply, and the bottom sphere is connected by a metal strip to the negative. And at the moment there's a large separation between the spheres, but we're going to adjust that in a second because we need them to be quite close together to gain a good reading on the top pan balance. You can see that the second sphere, the bottom sphere, is sat on the top pan balance. So now the experiment's set up, we're going to wind up the voltage so that the spheres gain charge and we can get a reading on the top pan balance. And this power supply will go up to about 5,000 volts or 5 kilovolts. So we're now taking some results, and you can see that on 0 volts, so before we've started, there's a reading of 0.02. We're now increasing the voltage up to 1 kilovolt or 1,000 volts, and we've got a reading of 0.08 grams on the meter reading. 1.5 kilovolts, and we've got 0.16, and so on. When the voltage reaches 4 kilovolts, in fact, what happens is that the air insulation of the air breaks down and the spheres start sparking between them, so the spheres are discharging continuously. And this means the force is much lower than we expect. So the reading for 4 kilovolts doesn't work, as you can see.